Okay. Bismillahirrahmanirrahim. We'll continue doing section 4.4, which is about what? Bases and the dimension. Okay. So the dimension of the subspace, this subspace. It's very clear. If I look at this subspace, what are the free variables? Very clear. They are B, C, and D. So I have three free variables, which give me the dimension. The dimension is the number of the free variables. Okay. A basis for the solution space of this system. Okay, we did something before. Let me do it again. For this one, 1, 2, 8, 2, 0, 3, 3, 3, 5, 0, 6, 5, minus 1, 9, 0. So what I will do, minus 3 R1 plus R2, minus 6 R1 plus R3. That give me what? I want the echelon form. So it will be 1, 2, 8, 2. This is 0. Minus 3, that will make it 0. Minus 3, that will give me minus 3. Minus 6 plus 3, minus 3. Minus 24 plus 3, that will be minus 21. Minus 3, that give me minus 6 plus 5, minus 1, 0. Now the next one, minus 6, 0. Minus 6 times 2, minus 12 plus 5, that give me minus 7, correct? Minus 12 plus 5, that is minus 7. Minus 48, that will be minus 49. Okay. Minus, how much? Minus 12 plus 9, that give me minus 3. 0. Okay. Yeah. So I want this to be 1. So multiply by minus 1 over 3. I have fractions, okay. Times R2. Okay. Be sure this is minus 12 plus 9, minus 3. Yes, correct. 1, 2, 8, 2. This is 0. This gives me 0, 1, 7, 1 over 3. 0. So I have 0, minus 7, minus 49, minus 3, 0. Okay. Now multiply the second row by 7 and add it to the third row. What you will get? 1, 2, 8, 2, 0, 1, 7, no, 0, 0, 1, 7, 1 over 3, 0. Now this is 0, multiply by 7 and add it. That will be 0. By 7, 49 minus 49, 0. 7 over 3, minus 1 over 3, minus 3, which is minus 6 over 3. Minus 9 over 3, that gives me minus, yeah, 7 over 3. This is minus 9 over 3. That will be minus 2 over 3. 0. Okay. Now if you want to write the equations, what are the equations? I have, now before the equations, what are the free variables? Okay. So I have, this is leading variables. I have x1, x2, x3, x4. So leading, 1, 2, 4, free, x3 only. So I need to write everything in terms of x3. Okay, what are the equation? We have x1 equal minus 2x2 minus 8x3 minus 2x4. Here I let x3 to be t. x2 minus 7x3 minus 1 over 3 x4. I have minus 2 over 3 x4 is equal to 0. So x4 is 0. x4 is 0. That implies x2 is what? x2, this is 0. Minus 1 over 3 times 0. Minus 17. And x1 will be what? This is will be 0, minus 2 times 0. So I have minus 2, x2, which is minus 7, that will be 14t, minus 8t, which is 60. So my solution, x, which I wrote it x1, x2, x3, x4, should be what? x1, which is 60, x2, which is minus 70, t, and the last one, 0. Take t as a common factor, what you will get? 6 minus 7, 1, 0. Oops. That means you have, this is V1, and they have only, so it's one-dimensional subspace, and the basis is only V1. Oops. Yeah, which is this one? 6 minus 7, 1, 0. Okay. Find out what the approach the following vector. They have 3 vectors in R3. They form a basis. To form a basis, it means they are linear independent. Since they form a basis. So I have V1. So I need the determinant of V1, V2, V3 not equal to 0. So I plug it here, 1, 7 minus 3, 2k4, k0, k. Okay. So multiply by minus, you get what? Minus and add. That will give me minus 7 and add. That will give me 0. Then give me k minus 14. K minus 14. Minus 7k. 3 and add, that will be 0. That will be 10. That will be 4k. This should not be equal to 0. So it's the determinant now. It will be k minus 14 times 4k plus 70k. It should not be equal to 0. So I have 4k squared minus 14 times 4. This is 56k plus 70k not equal to 0. So I have 4k squared plus 14k not equal to 0. Can take k. And they have what? 4k plus 14. Can take 2k actually. Yeah, can take 2k. And the remaining is what? 2k plus 7. Not equal to 0. It means k not equal to 0. And k not equal minus 7 over 2. So this is my answer. Okay. Next one, find the basis. He wants the basis. Okay, so we'll do the same strategy, which is I'll write the equation in echelon form, and then find the what we call the free variables and try to solve for these 3 variables. Okay. So multiply the first row by minus 2 and add it to the second, minus R1 plus R3. That gives me 1. 1 minus 3 minus 9 minus 5, 0. This will be 0. 6 plus 1, that will be 7. 14 plus 4, that will be 18 plus 4. This is minus 4, sorry. Yeah, be careful. 2, 1, yeah, minus 1, 3, 3, 13, yeah. No, it's correct. 18 minus 4, that will be 14. 10 plus 11, that will be 21, 0. Multiplied by minus 1 and add, that will be 0. Minus 1 and that will be 6. Minus that will be 12. Makes sense now. 5 plus 13, that will be 18, 0. So the second row by 1 over 7 and the third row by 1 over 6. Forget what. You know, no need for the third row. Yeah, it can be done, no problem. Yeah, to see it clearly. 0, this is the same. So multiply the second row by minus 2, by minus 1, and add to the third row. You get what? You get this. 0, 1, 2, 3, 0, 0, 0, 0, 0, 0. So what are the leading and what are the free? These are the leading and these are the free. The most important is the free variables, which are x3, x4. So I let x3t, x4 s. Okay, I have x1 equal what? 3x2 plus 9x3 plus 5x4. And I have x2 is what? Minus 2x3 minus 3x4, which is minus 2t minus 3s. Okay, that means x1 will be what? Be careful. Minus 6t minus 9s plus 9t with s. That give me what? 3t minus 4s. So my solution, which is x1, x2, x3, x4, will be what? Will be 3t minus 4s. x2 is what? Minus 2t minus 3s, t and s. Now, take t common factor. What you'll have? 3 minus 2, 1, 0. Take s common factor. Minus 4 minus 3, 0, 1. So this is V2. So I have two-dimensional bases V1, V2, which is this. Yeah, 3 minus 2, 1, 0, minus 4 minus 3, 0. Okay. This is subspace defined by this. Find the bases. You want us to find the bases. Okay. So I have A equal B plus C plus D. That implies the element. I can write it as B plus C plus D. I can write B equal T, S equal C equal S, and D equal R, and do that, or I can do it right away. B, C, D. Now if I take B, what are the three variables? Yeah, this is the most important point. The three variables B, C, D. Freely, I can put any value for B, C, and D, and B will be the leading variable. Okay, so B, if I take B, I have 1, 1, 0, 0. If I take C, I have 1, 0, 1, 0. If I take D, I have 1, 0, 0, 1. So those are my V1, V2, V3. So I have three-dimensional, which is the free variables, and the bases are V1, V2, V3, which is 1, 1, 0, 0. Okay, 1 0 1 0 1 0 0 1, which is this answer. Find the solution space. No, let the solution space has all linear combination of the following vectors. Okay, what he did, he put variables here. So after I do the calculation, I check these two variables, and I add them. Okay, do the same strategy. Oh, let it be red. I have 1 minus 2 minus 9 7 0 1 1 3 4 0 1 4 15 1 0. So minus R1 plus R2 minus R1 plus R3. That give me what? 1 minus 2 minus 9 7 0. That will be 0. 3 12 minus 7 plus 4 minus 3 0. 0 minus 6 9 plus 15 24 minus 7 plus 1 minus 6 0. So I can multiply the second row by 1 over 3 and the third row by 1 over 6. That give me what? 1 minus 2 minus 9 7. I think we did a lot of problems. 1 4 minus 1 0, and this is the same. We divide by 1 over 6. We divide by 6. Okay. Now minus R2 plus R3 give me this 1 4. No, it is 0 1 4 minus 1 0. So you have 0 0 0 0 0. Okay, so what are the free variables? Free variables. Yeah, this is x1, this is x2, so you have x3, x4. Let x3 equal t and x4 from this. Okay. Now, what I will do, yeah, I calculate x1. x1 will be what? 2x2 plus 9x3 minus 7x4. And x2 will be minus 4x3 plus x4. And that will be minus 4t plus s. And that implies x1 will be what? Oops. Good. So we'll start the questions from the book. Okay. Minus 8t multiplied by 2 plus 2s plus 9t minus 7s. And that gives me what? T minus 5s. Okay. So my solution, my element will be what? T minus 5s. x2 is what? Minus 4t plus s, t, and then s. Take one factor. You have what? 1 minus 4, 1, 0. Take s common factor. You have minus 5, 1, 0, 1. Okay. So this is V1 and this is V2. So it's two-dimensional. And the bases are what? V1, V2. This is this, done. This one means this is alpha and this is beta. So alpha plus beta minus 5 plus 0 minus 5. Okay. Now we'll do the questions from the book. I try to select some questions which explain what we have in this section. 1, 2, 3, 4, 7, 10, 15 questions. Okay, let us do them quickly. What we have here? We have here mainly, we want to check they will form a basis or not. That's mainly what we have. Okay. What's the idea? I know if the number of vectors quality k equal to n, there is the possibility to check the independent or not through the determinant. If k less than n, does not form, not form. If k is greater than n, also do not form basis. So the only case where I have possibility is if k equal to n. Okay, let me do number one. I have what? Two vectors in R2. It means k, which is 2, equal n, which is 2. So k equal n. So what I will check? I check the determinant. Check the independent or not. That's what I need. 4, 7, 5, 6. That will be 24 minus 35. I don't care what is the answer, not equal to 0. So V1, V2 are linear independent. So they form a basis. Okay. Number 2. I have what? 3 vectors in R3. I have 3 vectors in R3. So it means k equals 3 equal n equals 3. So k equals 3. I'll do the same thing. Check the determinant. What are the determinants? I have 3 minus 1, 2, 6 minus 2. You know what? No need to check the determinant. You can do it right away. Why? Because if you notice, V2, this V2 is 2V1. Notice 2 times 3 is 6, 2 times minus 1 is minus 2, 2 times 2 is 4. So I can do it. I can prove in V1, V2, V3 are linear dependent by the relation. I can say C1, V1 plus C2, V2 plus C3, V3 not equal to 0. I can show I can have those C's, not all zeros. Now, notice I can put C1, 2, and this is minus 1, and this is 0. So they are linear dependent. So that means what? They don't form a basis. If we do it through the determinant, for sure the determinant should be equal to 0. Okay, 3. I have what? I have 4 vectors in R3. 4 vectors in R3. How many vectors? 1, 2, 3, 4 in R3. So it means K, which is 4, greater than N, which is 3. So in this case, for sure, they don't form a basis. Why? Because they are linear independent. They are linear dependent. So they don't form a basis. 4, I have what? 1, 2, 3. I have 3 vectors in R4. Why it's R4? Because very clear, this element has 4 components, so it's an R4. But this vector. So K, which is 3, greater than N, which is 4. So they cannot span R4. So they don't form a basis. Okay. Now we'll come to number 8. I have what? 4 vectors in R4. So I need to check the determinant. Check they are independent or not, which is, it seems to be easy to check. I have 2, 0, 0, 0, 0, 3, 0, 0, 0, 0, 7, 6, 0, 0, 4, 5. Okay, so I'll do the expansion for the first row. So I have 2. What's the remaining? Cancel this with this. So I have 3, 0, 0, 0, 7, 4, 0, 6, 5. Now do the expansion also with the first row. So I cancel this with this. What's the remaining? 35 minus 24. I don't care what's the number. Just they are not equal to 0. So they are independent. It means they form a basis. Okay. So we did these 5 questions. So we have 3 don't form bases and 2 form bases. Okay. Now we need to find the bases for these subspaces. So the first one, what is the subspace? Call it V, call it W, call it the way you like. It's X, Y, Z, such that X minus 4Y plus 7Z equals 0. In other words, this is, I can think of it as X equal 4Y minus 7Z. Okay. Why I think of it this way? Because now it's very clear I have 3 variables, Y and Z. So I can write the element as 4Y minus 7Z, Y and Z. In terms of these 3 variables, I take Y, I have 4, 1, 0, I have Z, minus 7, 0, 1. So those will be V1, V2. So it's 2-dimensional, and the basis is V1, V2. Okay. Or 1, 0 minus 7, 0, 1. Okay, good. I'm checking the answer is correct. Okay. 10. You have what? Same thing. V equal X, Y, Z, such that Y equal minus T. Be careful here. So I have Y equal minus Z. What are the 3 variables? I can think of Z. Yeah, very clear. And you need to be careful here. X is a free variable because I can put X any value. There's no restriction in X. And Z, I can put it any value. Y will depend on the value of Z. So the free variables are Z and X. It means I need to deal with these two free variables. So I have X, Y, and Z will be what? X, Y is minus Z, and Z. I take X common factor. I need the free variables plus Z, 0, minus 1, 1. And those give me 0, and that will give me this is V1, and this is V2. So I have 2-dimensional, and the basis will be V1, V2. Okay, let me move. Next group of questions. No, still this one, 11. 11 is what? The line of intersection. So I want the space X, Y, Z, such that what? Both equations. I have both equations. Y plus Z equals 0. Which I can do using the echelon form. This is 1 minus 4, 7, 0, 0, 1, 1, 0. It's ready now. So I have the free variables. This is X, this is Y, this is X, this is Y, this is Z. So I can write the free variable is Z only. So let Z equal T. So what I have for Y minus 7Z and Y equal minus T, which is minus T. That implies X equal what? Minus 40 minus 70 minus 11T. So X, Y, Z will be minus 11T minus T and T. Take T, common factor, which is the free variable, minus 11 minus 1, 1. So this is my V1. So it's one-dimensional because I have only one vector, and a basis is V1. Okay, double check. Yeah, minus 11 minus 1, 1. Good. And the others, I think they are okay. Yeah, I checked them before. Okay. Now let me move to this group of questions. The same idea. But now these are set of vectors. So number 12, I have V is what? A, B, C, D, such that A equal B plus C plus D, which I can write right away. I can say A, B, C, D. Yeah, what are the free variables? Free variables. Very clear, B, C, D. So this one I can rewrite it. I think we did it before, no problem. Do it again. B, C, D. I take B, have 1, 1, 0, 0. Take C, common factor, 1, 0, 1, 0. Take D, common factor, 1, 0, 0, 1. It means this is V1, V2, V3. So I have three-dimensional and a basis V1, V2, V3. Correct? 12 is three-dimensional. 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1. Okay. Now move to the next one. 13. What is it? Is it all vectors? So I have A, B, C, D, such that what? I have A equals 6D and B equal 5C. Okay. So if I plug it, what are the free variables? Free variables. This is the most important. Very clear. I have C and D. Think about the free variables, the variables where I can put any value for these variables. So they are C and D. If I write it this way. Okay. So I have A, B, C, D. That will be 6D, B, B which is 5C, sorry. 5C, C and D. I'll write in terms of three variables. Take C, common factor. I have what? 0, 5, 1, 0. Take D common factor. I have 6, 0, 0, 1. So that means I have this V1, this is V2, so it's two-dimensional. I have two vectors for the bases. And what are these two vectors? V1, V2. Yeah, 0, 5, 1, 0, 6, 0, 0, 1. Correct. Okay. Next one, 14. What I have? This is V, A, B, C, D, such that A plus 8C equal B plus 7D equals 0. Okay, so I have 8 plus 8C equals 0, and I have another equation, B plus 7D equals 0, which is similar to the previous one, where I have A equal minus 8C, and I have B equal minus 7D. So what are the free variables? You can rewrite it in a different way, but this is one way, C and D. Okay, so the element, as I said before, sometimes you can write it equal to T, or you cannot, it's up to you. You can do it right away. Minus 8C minus 7D, C, D. Take C, minus 8, 0, 1, 0. Take D. I have what? Yeah, I have 0, minus 7, 0, 1. Correct? Minus 8, 0, 1, 0. 0 minus 7, 0, 1. Okay. So it's two-dimensional, and the base is V1, V2. Next one, I have 2 more questions to go. Okay, now I need to find the basis for the solution space. Yeah. 16. So I need to write the system 1, 3, 4, 0, 3, 8, 7, 0. So multiply by minus 3, R1 plus R2. We get what? 1, 3, 4, oops, 0. Minus 3 and add, that will be 0. Minus 3 and add, that will be what? 2. Minus 3, minus 12, plus 7. Is it? 1, 3, 4, 3, 8, 7. Yes. 1, 3, 4, 3, 8, 7. Okay. Okay. Multiply by minus 3 and add, that will be 0. Minus 3, minus 9, sorry. Minus 9 plus 8, that will be minus 1. Minus 3 times 4, times 4, that will be minus 12. Plus 7, that give me minus 5, 0. Multiply the last row by minus 1 to make it better. So it's 1, 3, 4, 0, 1, 5. Don't forget 0, 0. So how many free variables I have? Yeah. So I have this, x1, x2. So I have 1 free variable. Yeah. So the free variable is x3. And they have what? x1 minus 3x2 minus 4x3. x2 minus 5. So I let, yeah, x3 equal t. You can do this, you cannot. That's okay, it's up to you. Minus 5x3 minus 5t. So x1 will be 15t minus 4t, which is 11t. So my element, my x will be what? x1, which is 11t, x2, which is minus 5t, and x3, which is t. So I have t, 11 minus 5, 1. So I have how many? I have only one v1, so it's one-dimensional, and the base is v1 only. 11 minus 5. Okay, next one. 17. I have this one is 1 matrix minus 3. Be careful, 2 minus 4 0. And this is 2 minus 5, 7 minus 3, 0. What I will do, I will multiply the first row by minus 2 and add it to the second row. Let me see what will happen. I have 1 minus 3, 2 minus 4, 0. Inshallah, there is no mistake. Yeah, 1 minus 3, 2 minus 4. This is 2 minus 5, 7 minus 3. Correct. Multiply minus 2 and add, that will be 0. Minus 2 times minus 3, that will be 6 minus 5, that will be 1. Good. Minus 4 plus 7, that will be 3. Minus 2 minus 4, minus 2 times minus 4, 8 minus 3, that gives me 5. 0. Good. So what are the free variables? Free variables. I can take them x3, x1. So I have two-dimensional vector space. Okay. So I have x1, let x3 equal t and x4 equal s. So x1 will be 3 x2 minus 2 x3 plus 4 x4 x2 minus 3 x3 minus 5 x4, which is minus 3t minus 5s. So that implies x1 will be what? Minus 90 minus 15s, correct? Okay. Minus 2t plus 4s, which is what? Minus 11t minus 11s. So x1, x2, x3, x4 will be what? x1, plug it, minus 11t minus 11s. x2, where is it? Minus 3t minus 5s. And this is t and s. Take t as a common factor. You have minus 11, minus 3, 1, 0. Take s common factor, minus 11, minus 5, 0, 1. That's minus 11. Where is it? Yeah, minus 11, minus 3, 1, 0. Minus 11, minus 5, 0, 1, which is correct. Oops. So this is V1, this is V2. So you have two-dimensional subspace, and the bases are V1, V2. Okay, 23, 2 to go. 2 to finish this section. 23. What I have in 23? Be careful now. 1, 2, 8, 2, 0. I think I did it before. Let me do it again. 5, 0, 3, 3, 3, 5, 6, 5, minus 1, 9, 0. Okay. So I need to multiply the first row by minus 3 and add the second row. The first row by minus 6 and add it to the third row. I can do it at one time. 1, 2, 8, 2. This is 0. Multiply minus 3 and add, that will be 0. Minus 6 plus 3, that will be minus 3. Minus 24 plus 3, that's minus 21. Minus 6 plus 5, that will be minus 1. Okay. 0. Is it? Yeah. Minus 3 times 2, minus 6 plus 3, that gives me minus 3. Minus 24, minus 21. Minus 6 plus 5, that's minus 1. Okay. Now minus 6, that will be 0. Minus 6, minus 12 plus 5, that gives me minus 7. Okay. Minus 12 plus 5, minus 7. Minus 48, that gives me minus 49. minus 12 plus 9, that gives me minus 3, 0. Okay. Okay. So I divide the second row by minus 1 over 3, by minus 3, or multiply by minus 1 over 3. That gives me what? 1, 2, 8, 2, 0, 0, 1, 7, 1 over 3, 0. So I have 0, minus 7, minus 49, minus 3. Now multiply the second row by 7 and add it to the third row to get what? 1, 2, 8, 2, this is 0, 0, 1, 7, 1 over 3, 0. Multiply by 7, that will be 0. Multiply by 7, that will be 0. I have 7 over 3 minus 9 over 3. That gives me minus 2 over 3. And that will be 0. Okay. Now what I need to do, I need to check the free variables. Okay. What are the free variables? Notice this is the leading ones. So the free variable only x3. Need to write everything in terms of x3. Okay. So I have x1 equals, I let x3 equal t. Okay. So x1 equal minus 2x2 minus 8x3 minus 2x4 x2 minus 7x3 minus 1 over 3 x4. And the last one, I have minus 2 over 3 x4 equals 0. So x4 equals 0. And that gives me x2 equal minus 7t. And that gives me in x1 is what? 14t minus 8t, which is 60. So my element, which is x1, x2, x3, x4, well, my vector, I mean, the general one, it will be 60 minus 70, t and 0. So take t, I have 6 minus 7, 1, 0. So we have V1 only. So it's one-dimensional, and the basis will be V1. Okay, now the last one, 24. A little bit of calculation. Let me check it. That we have what? 1, 3, minus 4, minus 8, 6, 0. I have 1, 0, 2, 1, 3, 0. I have 2, 7, minus 10, minus 19, 13, 0. So multiply the first row by minus 1 and add the second row. The second row, let's say first row by minus 2 and add it to the third row. Let us see what will happen. So you have 1, 3, minus 4, plus 8, 6, 0. Okay, multiply minus 1 and add, that will be 0. That will be minus 3. By minus 1 and add 4 plus 2, which is 6. Minus 1 and add, that will be 8 plus 1, which is 9. Minus 6 plus 3, that will be minus 3, 0. Good. Minus 2 and add, that will be 0. Minus 2 and add, that will be 1. Okay. Minus 2 and add 8 minus 10, that will be minus 2. 16 minus 19, that will be minus 3. 12 minus 12 plus 13, that will be 1. Now I can multiply the second row by minus 1 over 3 to get what? 1, 3, minus 4, minus 8, 6, 0, 0, 1, minus 2, minus 3, 1. 0. And this is the same. So I have minus R2 plus R3. Give me what? 1, 3, minus 4, minus 8, 6. That will get the 0, 0, which is no need for it. 1, minus 2, minus 3, 1. The last one will be all zeros. Okay. Now I need to be careful of the calculation. I have the free variables. I have 3 variables. Yeah, 3, x3, x4, x5. Let x3 t, x4 s, x5 r. Who cares? Okay, and they have x1 equals what? Minus 3x2 plus 4x3 plus 8x4 minus 6x5. Okay, and x2 equals what? 2x3 plus 3x4 minus x5. And that gives me what? 2t plus 3s minus r. Plug it here to get x1 equals what? Minus 3 times this. Yeah, it will be minus 6t minus 9s plus 3r plus 4t plus 8s minus 6r, which is minus 2t minus s minus 3r. Okay, now it means the element or the vector, which has 5 components, would be what? x1 minus 2t minus s minus 3r. Oops. And this is x1, x2, 2t plus 3s minus r, and then t s r, which is x3, x4, x5. That I can take t common factor to have what? To have minus 2, 2, 1, 0, 0. This is t. Okay, good. S have minus 1, 3, 0, 1, 0. They have R, which is minus 3, okay, minus 1, 0, 0, 1. Okay, so I have how many vectors? I have 3, V1, V2, V3. So it's 3-dimensional, and the bases are V1, V2, V3. Okay, I think that's enough for this section. For point 4, and I will stop the recording. Thank you.